everyone. Do you know how does the gas exchange take place? What factors affect it? This class will learn gas exchange. Gas molecules move freely from high pressure to low pressure. In a mixture of gases, each gas exerts a partial pressure proportional to its mole fraction. For example, the air total pressure at sea level is 760 millimeters of mercury. The mole fraction of oxygen is 21%. So the partial pressure of oxygen is 760 multiplied by 21%. Gas exchange is the process of physical diffusion. The diffusion rate is directly proportional to the partial pressure of difference, solubility, diffusion area, and temperature, and inverse proportional to the square root of gas molecule weight and the diffusion distance. Calculate from the formula. In length, the diffusion rate of carbon dioxide is twice of oxygen. Therefore, in pulmonary dysfunction, oxygen deficiency is more common than carbon dioxide retention. So, patients with dyspnea often appear hypoxia first. Next, introduce the process of gas exchange. First, pulmonary gas exchange. Partial pressure difference of oxygen between alveoli and blood is 64 millimeters of mercury. Therefore, oxygen diffuses from alveoli into blood. The partial pressure difference of carbon dioxide is 6 millimeters of mercury. Therefore, carbon dioxide diffuses from blood to alveoli. After pulmonary gas exchange, venous blood turns into arterial blood. Generally, oxygen and carbon dioxide diffuse rapidly and reach the balance in less than 0.3 seconds, while the blood flows through pulmonary capillary for about 0.7 seconds. So, there's sufficient time for gas exchange. Tissue cells consume oxygen, produce carbon dioxide. So, both oxygen and carbon dioxide have a partial pressure difference between tissue and blood. Therefore, internal respiration takes place, and arterial blood turns into venous blood. Pulmonary gas exchange is mainly affected by 3 factors. The first is the thickness of the respiratory membrane. The respiratory membrane contains 6 layers, but it's very thin. The average thickness is only 0.6 micron, so gas diffuses rapidly. With pulmonary edema, fibrosis, pneumonia, the thickness increases. The efficiency of gas exchange decreases. In normal adults, there are more than 300 milli alveoli in both lungs. The total area is about 70 square meters. At rest, 40 square meters is enough for gas exchange, so there's a big area reserve. If the area decreases greatly, the efficiency of gas exchange would decrease. The third is ventilation-perfusion ratio, which is the ratio of alveolar ventilation and pulmonary blood flow. In normal adults, the alveolar ventilation is adapted with blood flow. The ratio is 0.84. The efficiency of gas exchange is the highest. In hyperventilation or insufficient perfusion, the ratio increased. Dead space increased. If ventilation was insufficient, the ratio would decrease. Blood flow through poorly ventilated alveoli can't get enough oxygen. Thus, whether the ratio increased or decreased, the efficiency of gas exchange would decrease. The lung has the ability to regulate the local ventilation-perfusion ratio. In the poorly ventilated alveoli, the low oxygen in alveolus can make the vessels around it contract and reduce the perfusion. This allows the blood flows to the alveoli well ventilated, conducive to gas exchange. Internal respiration is affected by the metabolic level and the blood flow. The blood flow is adapted to the metabolism. If the blood flow is blocked, gas exchange would decrease. In edema, the distance between cells and the capillary increases. Meanwhile, the capillary is compressed, thereby the gas exchange decreases. Let's do a summary. Gas exchange takes place in lungs and tissue. The diffusion of carbon dioxide is faster than oxygen. So, in dyspnea, hypoxia appear first. The main factors affecting gas exchange in lungs are the thickness and area of respiratory membrane and the ventilation-perfusion ratio. The normal ratio is 0.84. The efficiency of gas exchange is the highest. No matter the ratio increase or decrease, the efficiency decreases. That's all for this class. Thank you. See you.